All right, we're going to start off with a basic net force problem. So this is example number 1. Sarah pushed her friend Charlie on a skateboard on her driveway. Charlie and the skateboard had a total mass of 65 kilograms and accelerated to the right at positive 7 meters per second squared. What is the net force acting on Charlie and the skateboard? All right, for every force problem, you want to start first analyzing the situation and understand if it's balanced or unbalanced. Because we have an acceleration, it's going to be unbalanced, so that means our free body diagram needs to show that as well. So let's start by drawing our free body diagram. Since we're on Earth, we obviously have the force of gravity pulling down towards the center, and we're on the surface of the driveway, so we have my normal force counteracting the force of gravity, and those two can cancel each other out. We don't know those values, and it really doesn't matter. Now, we have an acceleration, a positive acceleration to the right, so that means my force applied, if it's a positive acceleration, is going to be greater than my force of friction, and that means I'm speeding up. So I'm going to put that to the right, and then my force of friction would obviously be opposing that. And again, because I have a positive acceleration, my applied force is going to be greater than my force of friction, in which my diagram shows that. Again, this is unbalanced. So now, what do we know from our information? We know that the mass of the skateboard and Charlie is 65 kilograms, so we place that inside the free body diagram. Also, just to keep my thoughts organized, I'm going to put it outside like that. Then we also know that there's an acceleration, like we said, it was positive acceleration of 7 meters per second squared to the right. And if we remember back in the force unit, acceleration is a vector quantity, so not only does it need a magnitude, but it also needs a direction, just like force does. And then we are asked to find net force, which we don't know. So as of right now, we have enough information, and we know Newton's second law is F net equals mass times acceleration. So if we plug in our information, so we have F net, which is our net force, times mass, which is 65 kilograms, times positive 7 meters per second squared to the right. Okay, now since I have these two magnitudes, all I have to do is plug these two 65 times 7 in my calculator, and I should get the magnitude of 455. Now, force is always in newtons, so this should be newtons, and again, it is a vector quantity, so it's to the right. Now, how does it come about? How does a kilogram a meter per second get to a newton? We've done this before. This is not something that you would be needing to remember, but just to give you a heads up, 1 newton equals 1 kilogram meter per second squared. So if I multiply those two cancel out, and that's the same thing as newtons. Again, this is not a conversion that you need to know. It's just the understanding of how we get newtons out of these two. Okay, so if I recap, I did my force diagram, I looked at all my information, I plugged it into my equation, finding net force, and I came out with 455 newtons to the right.